Well, good morning, everybody, and welcome to this special seminar today. I'm really excited to introduce to you Tim Dixon from IEAGHG. He is the Director and General Manager of IEAGHG, and this is an international research organization focusing on carbon capture and storage. And Tim has extensive experience in CCS. He's been basically negotiating every international regulation there is on CCS since the early days. So he's been very active in the United Nations Framework Convention on Climate Change, and he has been a valuable collaborator of the Gulf Coast Carbon Center ever since he became an honorary senior research fellow with our group since 2014. And he's been a real valued partner in helping us with our offshore workshop series, which began in 2016, and now we're planning the 7th iteration of it. So it's been extremely successful. And we've also worked with him in the United Nations Framework Convention on Climate Change, helping developing countries to get funding for CCS, and then for also the technology transfer that we have at the Gulf Coast Carbon Center, because we have a lot of technical expertise that we want to be able to transfer to developing countries. So I think so Tim has a degree in applied physics and an MBA from Oxford Brookes University. And I think he has some really exciting developments to talk to us about today. So I'm really happy to have you, and let's welcome Tim.
Thank you very much, Catherine. And can I just check I'm audible through the microphone and people online can hear me? Okay, thank you for the introduction, and thank you very much for the opportunity to come and talk today in this special seminar. What I've got to share with you is both old material and new. And I'm assuming I'm talking to a CCS knowledgeable audience here. I've got some of the leading experts in the world in the room. But what I want to show you is what I've showed other people. It's in that context. And then there'll be some new information at the end. So this is titled The International Development in Offshore Carbon Capture and Storage Deployment. And also I am very proud to be an honorary senior research fellow here. Thanks for that. And I used that this week because I've come here from Trinidad and Tobago, where on Wednesday they launched a new initiative by the 2 universities there, a research center initiative on CCUS. And at the same time, they announced that they got funding from the Green Climate Fund for funding some of their activities. Now, for those of you who don't know, that is the largest climate finance fund there is for developing countries. It's been operational for about 10 years. It's about $11 billion total. They've got a small bit, but it's an important precedent-setting announcement because they've been reluctant to fund CCS to date. We've been working with trying to get countries to get funding, and this is the first one to get over the line. Small island state makes it more insignificant. So that's big news for the rest of the world. It's good for Trinidad and Tobago, but it's bigger news for the rest of the world, developing countries going forwards. So I come here from there to share that good news with you as well. But what I'm talking about today is it's in the context of the London Convention. And this is the marine treaty, the global marine treaty that protects the world's oceans against originally dumping of nasty industrial waste, but it's broadening its scope to protection in general of the world's oceans. And I might say London Convention and I might say London Protocol. They're effectively the same thing. The protocol is the new version of the London Convention, but it's about 80 countries. And they meet every year for the country government leads. And then we meet once a year also for the science part of that. And we've just had the science meeting a few weeks ago in London. And what I want to share with you today is what I presented there, because they have a new interest in CO2 geological storage. And they're doing an exercise looking at that. And it's a very interesting environment because we have environmental NGOs sat at the table. So it's different to the UNFCCC, which is just negotiated by governments to governments, and environmental NGOs are on the outside. This has environmental NGOs on the inside with the seat at the table in the London Convention. So I want to share with you what I shared with them and then share with you the feedback I got or that they gave. So there's two aspects to this talk today in that context. So the first part I drew upon, there was this excellent offshore CCS workshop series that the University of Texas BEG started. They had the idea, and the Carbon Sequestration Leadership Forum formed a task force. It became a recommendation to share knowledge. And then we've been working with you ever since 2016 in this offshore workshop series. So I drew upon that to input to the London Convention meeting 2 weeks ago. And so half of this is that material. So some of you will be familiar, some of you who couldn't go to the meetings, I'll run through very quickly on what was presented. So that's the standard disclaimer. Don't need the thing. That with IEAGHG, we're not the International Energy Agency. We were set up by them, but we're separate from them. So anything I say does not count as their views. That's our disclaimer. And in the London Convention, I started off because 80 countries, these are delegates from the marine protection bodies of those countries. So they're not necessarily at all CCS experts. I start off by showing this cartoon that tells people what CCS is. And then I point out the one fault with this is the scale, because that's the scale of storage. And this is the Boundary Dam, this is the Aquastore part of Boundary Dam, 3 kilometers deep storage reservoir, and all the different strata in between. Helps you people to understand then the scale of the depth of CO2 geological storage. And you know, we go at least 800 meters deep. This is 3,000. I then also explained the need for CCS. It's in the Intergovernmental Panel on Climate Change, the main science body that inputs to UNFCCC. They do their assessment reports. They produce their scenarios for emissions and climate and warming going forwards. And in all the scenarios, there's a need for CCS to a greater or lesser extent. And the one that has the lesser extent is the most expensive. They do realize that to try and achieve the climate goals that the politicians have agreed, to do it without CCS is a lot more expensive. And that came through in the most recent reports last year and the year before from their AR6 process. And that they also summarize that the potential geological storage for the role of CCS, there's more than enough storage in theory on the planet, but there's a need for more policy instruments. I made that point to these countries in the London Convention. And then my colleagues in the International Energy Agency, they produced their nice reports that summarize the need for CCS, its application to different sectors, especially the hard to abate sectors, and the scale out of CCS needed in their net zero roadmap for the energy sector to achieve net zero by 2050. We're looking at 4 gigatons of storage by 2035. That's 100 times more than we're doing today. So we have to scale up as a key message. And then with the launch, at the Major Economies Forum meeting in April last year, President Biden wanted to announce the Carbon Management Challenge to scale up carbon management in terms of CCS and engineered carbon dioxide removal. And this was underpinned by this IEA report, realizing that we're not moving fast enough in mitigation in general. So 4 pillars for action in the 2020s, decarbonizing electricity, reducing deforestation to zero, tackling methane and carbon management through CCS and CDR. It's a big political announcement because this, out of all the technologies for mitigation, this is the one that's probably achieving the least. And that fed into the launch at COP28 in Dubai of the Carbon Management Challenge formally. So this is country to country agreement to scale up collectively their activities to a gigaton scale collectively by 2030, CCS and CDR. The significant bits of this, as well as the 20 countries that are in it, is in the lead countries, US, Canada, UK, but also Brazil and Indonesia, 2 developing countries, putting their names up front, leading on this. So this is a big political message, particularly in that COP where there was a lot of misinformation on CCS and negativity. This was a big political outcome from that. And, you know, it was great to be invited to the launch event of that, to sit at the same table as John Kerry in this launch. It was a big table, 50 people, but I got a seat at the table. Catherine was in the room as well. But it's significant for the message it gave of endorsement for this technology that gets a lot of criticism from environmental NGOs. And then I showed also, so that's the message I gave to the London Convention. And then the most recent IEA's work showing that, yes, the pipeline of projects is good. I can move the mouse, I've got it. The pipeline of projects being in development is increasing. That's good. But even if all of those projects were realized, that's only a third of what we need by 2030 to be on the path to that net zero by 2050 pathway that the IEA produced. And the role of CCS overall, we need all those mitigation activities. It's actually getting smaller. Each time they do these updates, it's getting smaller because we're not deploying projects at the rate that was originally envisaged. So it's now only between 8 and 10% of the overall mitigation because we're not doing it fast enough. And the last message from the World Energy Outlook last year, yes, CCS activity is going up, but current policies are wholly insufficient. So I wanted that message to get over to the government representatives in the London Convention meeting. It's a policy problem, not a technology problem, for the lack of deployment of CCS projects. So let me catch up to where I'm going. So then also, so what the London Convention countries need to understand is this is a climate change technology. So they're involved because their motivation is protection of the marine environment. But the reason people do CCS is for climate change benefits. And so this is putting it into that scenario, the Paris Agreement that we're in now. The countries have their NDCs, their nationally determined contributions. Each country says what they're going to achieve in emissions reductions. Not so many have got CCS in, it's true, but that's because they're looking to 2030 with these in the current NDCs. But what's more significant is that the Paris Agreement also requires countries to look to 2050, to mid-century, so they're in their low greenhouse gas emission development strategies. And this is good because it makes countries look beyond their political horizons and realize that in the NDCs, they're putting the easy to do things and they've got to go beyond those. So most of those have got CCS in coming into them as they realize they've got to go further in their greenhouse gas mitigation. And the ones that don't are generally ones that can't because they're small islands without CO2 sources. And I share my colleagues from the Global CCS Institute, their global status reports, nice map of project activities. And yet there's 325 projects in development. Might not all be realized, of course, but this is the distribution around the world to show it is there's global developments now. And then going to our nice workshop series that we've got in partnership, initiated from the University of Texas BEG here by Sue and Tip and Ramon, proposed to the Carbon Sequestration Leadership Forum. It produced a task force and a report with the recommendations for international knowledge sharing. And I start off also by showing this from Tip, his paper with Philip Ringrose in Nature, showing the potential for offshore storage is enough to meet the needs for CCS. We can do gigaton scale CCS, and the offshore is interesting because there's more likely to be single pore space ownership. So the confusion over ownership and multiple ownerships that you may get onshore is removed, but also the proximity of these sedimentary basins to major industrial activities, which tend to be along coastlines. So there's a good benefit of looking offshore for CO2 geological storage. And then the workshop series, the first 2016 hosted here, second at Lamar University in Beaumont in 2017. And IEAGHG, we produced the reports out of these workshops. So there's a written record of the presentations and the discussions and the conclusions. The third workshop, then the Norwegians wanted to host. And we go through, it's all about operational projects, how to get projects developed and deployed. These are the topics that we cover in these workshops. Fourth workshop, again, in Norway, in conjunction with the STEM CCS project, which was a European project developing monitoring for leakage detection and quantification offshore. They did a real controlled release at 110 meters water depth at the site that would have been the GoldenEye project and might still be a CCS project for the UK in the future. And you can see the topics that we cover in these workshops. And an intern from BEG, Parker Medford, took all that information on the countries being interested in CCS offshore and CO2 geological storage offshore, and the countries already operational. And I think here he put Gorgon, which is onshore injection, but offshore, the storage reaches offshore, put that down as green. So green for the active countries and blue for the countries interested. So a nice map again to make the countries, 80 countries of the London Convention realize there's global interest in offshore geological storage. And then our fifth workshop was in New Orleans in 2022. And we did this international project roundup. Got a lot of interest in doing this quick 5 minutes from all the projects that we knew of on their status of development or operation. And our last workshop was just in September last year, hosted by the University of Aberdeen and Storegga, which is a development, CCS development company. And that was the agenda, the topics that we covered. And just to go into a little bit more, so the projects that we had presented at this project list is growing. So we had projects from the UK, Greece, US, Gulf of Mexico, Portugal, Norway, South Korea, the Netherlands, Australia, Taiwan, Brazil, and Timor-Leste, who are looking at an interesting project where they will take CO2 from Australia, from Santos, from their LNG facility, and store it in a depleted gas field. The pipelines are in place because the natural gas production was in the opposite direction. And we did the projects you couldn't update in person, we provided summaries of as well. So the ones that we know of, they've been running for decades offshore, Sleipner and Snøhvit, Tamakama in Japan, the K12B in the Netherlands, the new project offshore in Denmark, Green Sands, and then the one they're developing, Bifrost, a new one in L10. Two projects are called Poseidon. There's one in the UK and one in Norway. Polaris in the Westmeyer Heer, they're going back to that reservoir. Woodside in Australia, Endurance Field, which is for one of the UK clusters, and more in the Gulf of Mexico here. And I added this on for the London Convention meeting, but we did not include an update on the Cliffhead project in Australia because we didn't know about it quite at that point. So we had an intern at IEAGHG, Naomi Clark. We like using the map that Parker Medford did. So this is a map of projects that are in development and operational. So not the countries, but the projects. And red are those using depleted oil and gas fields, and yellow is those using deep saline formations. None of them are doing EOR, and that's the point I made to the London Convention because that's not popular in climate circles, and it's not popular in the London Convention marine protection aspects either. So all of these are intended to do straight storage and not enhanced oil and gas production. And Naomi also looked at the characteristics of the projects as much as we could see, and to see, just make some generalizations. And so, yes, about just over a third are looking at storage in deep saline formations, over 50% storage in depleted oil and gas fields, and others are either both or not clear. Transport, about half is through pipeline from shore, and then for about 40% ship and pipeline, or 10% is just ship transport to an offshore structure or floating production and storage vessel. And in terms of infrastructure reuse, just over half are going to be reusing the infrastructure, and 16% will be new infrastructure in place. And with all of these workshops, we draw from the collective attendance conclusions and recommendations at the end. And these are the ones from the last workshop. Increasing number of projects, but not enough to meet the climate targets. Spatial resource allocation is strategic and very important. And that means not just in the pressure space that Alex presents on so well, but also in terms of use of the seabed with wind farms. The North Sea is very popular. It's quite shallow. It's very popular for offshore wind, but that puts a compromise in place for the monitoring ability for CO2 geological storage. And as you are finding here in the US onshore with Class 6, the time to permit is becoming a bottleneck in project deployment, the same in general in the world. And the UK North Sea Transition Authority were proud that they knocked a year off their permitting capabilities. And the fact that even though these projects are storing offshore, the fact that just transition is being required, engage with the public and the stakeholders onshore, make sure there's benefits to the local population from the onshore perspectives. One thing that was very positive is that the MMV plans are being approved by regulators on these projects. That's good. And it also sets a precedent for the level of monitoring required. I mentioned the community benefits, but also the tools for environmental monitoring. We've got various projects such as STEM CCUS, who've developed sensors and mounts for those and techniques and tested them for real in controlled releases. And there's a lot of work now published on that. And we've got confidence in the environmental monitoring aspects, certainly in the North Sea environment. But the last point was, yes, how can you do your seismic monitoring when you've got a population of wind turbines on the surface? And the next workshop we're planning will be this September at Port Arthur. We welcome ideas for the agenda and we'll be moving forwards with that. So then to the regulation part. So that is what I presented. And then I did a history lesson to the London Convention on the development of regulations. So apologies again, I'm repeating things you know already. But it's very important to start with the IPCC because they draw upon peer-reviewed material. They point out CCS will work at scale. It's worth pursuing for well-selected, well-designed and well-managed sites. How do we ensure they're well-selected, well-designed and well-managed? That's the role of regulations. And we have a raft of international regulations now on CO2 geological storage in particular, and we've even got ISO standards produced. And the IEA, my colleagues in the International Energy Agency, have produced a handbook for countries to develop their regulations as well. But all of these really start with the IPCC Greenhouse Gas Inventory Guidelines in 2006. It's followed from that special report. And they looked at, and what the IPCC guidelines are, every country follows these for all their greenhouse gas emissions, not just CO2. From all their activities, these are the guidelines they follow. And they're normally done on a calculation-based approach, an emissions factor approach, so much fuel going in, being used in a process, they can calculate what the emissions are. But with CO2 geological storage, you can't predict the emissions from storage because one, you're intending it not to leak. And two, the geology is so different in every site. So they chose what they called a monitoring or measurement-based approach, what they call a tier 3 approach, which is around site characterization, simulation and modeling of the CO2, and then monitoring of the CO2 in operation, and then reporting both the CO2 injected and if there was any emissions from the storage site. And using this tier 3 methodology, they were confident to say this supports a zero leakage assumption. So that's a very important precedent there, unless your monitoring indicates otherwise. And this methodology basically became the basis for all those international regulations and national regulations on CO2 geological storage. And this is 2006, so it's been in place for nearly 20 years. It may be revisited for the first time because there's a new development in terms of direct air capture and carbon dioxide removal from the atmosphere, these guidelines can cover bioenergy with CCS, BECCS, they can cover biochar, but they do not cover direct air capture at the moment. So it's a gap in them. And the IPCC is setting up a new work stream to address that gap. And they're having an expert workshop to kick that off in July this year. And Catherine Romanak's been invited to be one of the experts going to that workshop, which is very good. I wanted to be invited and I wasn't. I wanted my go-to expert, Paul Zakul, to be invited, and he wasn't. But Catherine has been invited, so that's a great significance, Catherine. Well done for being in there. And I think they certainly know that the geological storage methodologies are in existence and in place. They may revisit these in some way because it's 18 years on from them being developed. So we'll see. We don't want to go backwards on these in that. But the direct air capture part should be fairly straightforward to include as well. So then moving on to the London Protocol, the London Convention, as I described it at the beginning, how it works, it prohibits the dumping of wastes unless you're explicitly allowed to do it. If you are explicitly allowed to do it, you need a permit. And this was the first international body to work to develop a regulation on CO2 geological storage. It concluded in 2006 to amend itself to allow geological storage offshore, but also to produce some guidelines for what to do when issuing permits. And that's just a photo of me in one of the meetings. It's not meant to be a photo of me as much as showing these are UN-based meetings with the 7 UN languages translated in simultaneous translation there. And sat next to me in that meeting is Greenpeace and other environmental NGOs, but Greenpeace are very reliably active in these at every meeting. And at that point, so bear in mind, this is a history lesson I'm giving to the London Convention people, because that was 18 years ago. There's been staff turnover and change, and people have forgotten why things were agreed the way they were agreed then. And I showed this to them. This is Plymouth Marine Labs' early work, Jerry Blackford, Carol Turley's work. This was what made them move more quickly as 80 countries in 2006. As we were looking and doing the risk assessment on geological storage, what happens if it leaks? It was like a case of, oh my goodness, look at the impact of the CO2 from the atmosphere, causing the surface layers of the oceans to acidify. And that brown band is the band of the surface pH for the last 20 million years. And the yellow is where we've pushed it. And this is 2006, when we were working on the London Convention. We were at 380 parts per million CO2 in the atmosphere. If we get to 500, things like the coccolithophore, phytoplankton with calcium carbonate bodies, they won't be able to exist. So it's a real big risk to the ecosystems and through the seawater chemistry changes. So we were at 380 then, I pointed out to the London Convention parties, and now we're at 420 parts per million CO2, significantly along. And when we were confident at doing CCS at scale, about 10 years ago, we were about 390 then. So we've gone from 390 to 420, with my implication being because we've not been doing enough CCS. So a lot of the discussion then for the in this work, realizing that CO2 will not be pure, there will be other incidental associated substances in with the CO2 stream, depending upon the capture technique, whether it's amine capture, what the fuel was used. And there was a long discussion around this term on how to specify what the CO2 purity should be. And Greenpeace wanted to say 99.9% pure CO2 in the CO2 stream. And that was because they didn't like CCS and they didn't want the amendment to go through. They wanted to make it unoperable. So we looked at the different capture technologies. And at least, this is 2005, 2006 work, early days. Amines could get up to that level, but oxy-fuel-based capture would get to 94, 95% CO2. and there'll be other technologies we don't know yet. So we settled on the term of overwhelmingly. It gives the intention without quantifying it. And it acknowledges there may be other substances in there as well. So that was the purpose of this. And Greenpeace didn't like it, but that's what the countries voted for in the end. Also, you know, at this time, in arguing against quantifying this amount, Greenpeace, they produced a formal paper into the London Convention on this, 99.9%. We pointed out that, you know, existing projects, Sleipner was in operation then, and that's 96% CO2 in their CO2 stream, the rest is nitrogen. So that project wouldn't be able to proceed if they put their 99.9% in. We've got lots of experience with acid gas injection in North America with much lower rates of CO2. A compound of concern is H2S. And at this time, we had in the UK a BP proposed project, DF1, into the Miller oil reservoir. And the Miller field is very rich in H2S. So putting a limit on H2S going into something that's very rich already, and the pipeline setup is designed to cope with the H2S, didn't make sense either. So those are the sorts of arguments that we used, and we ended up with the term overwhelmingly. But we also then recognized in the guidelines that this is the last bullet point here, that is the one I'm referring to. It's not the level of CO2 in the CO2 stream that's important, but it is the level of the other incidental associated substances. So there should be an assessment of those. There should be a risk assessment based assessment of those incidental associated substances based upon their impacts on the storage site and the transport infrastructure. And of course, that's going to be different on every geological storage site, and it should be on a site by project basis. So that's an interesting concept, which we will come back to in a moment. And then the regional interpretation of this treaty is OSPAR. They apply the same principles to the same guidelines as London. And that's the process that projects have to demonstrate and regulators have to be happy with, that basically an environmental impact assessment process has been undertaken. Specifically in the CO2 specific guidelines, there's about 56 requirements. They're qualitative in nature, not quantitative. But these were based upon the guidelines for any material that's dumped in the oceans. And they were just they took the same headings and made them relevant to CO2 geological storage. So with all wastes, they require a waste prevention audit. We'd rather you weren't dumping this in the oceans. If there's no other options, okay, we'll do it, and you'll need a permit. So that's why that's in there. The chemical and physical properties, that's in this case of the CO2 stream, an action list of things that are not allowed in the CO2 stream to get into the marine environment. And then the site selection and characterization, yep, as we know on the CO2 storage reservoir, and also the marine area above it, characterization of that, and then assessment of potential effects if there is a leakage, risk assessment, all concluding in an impact hypothesis, and then a monitoring and risk management plan, and mitigation and remediation. So that's what's in the CO2 specific guidelines that countries should follow when permitting CO2 storage offshore. Now, I mentioned Greenpeace. Greenpeace are very active in these meetings, and they started to complain that there was offshore projects in operation or in development, and they were not sharing, the countries were not sharing the permitting experiences, the permitting information. And because of their protests recorded in every meeting, we thought, well, in the European system, the road project, as it was then, had recently got its permit from the European CCS directive. The European CCS directive's requirements are very similar to OSPAR, because most of OSPAR countries are European, and OSPAR based theirs on the London Convention CO2 guidelines. So they should be pretty closely, compliant. So we contracted TNO to look at the Dutch language documents for the permit application and the environmental impact assessment, about 1,100 pages of material. Unfortunately, that project didn't proceed, but that P18 field is the one that the Portos project is now looking to use. So it's now active again, but with a different CO2 source. So we did this for the London Convention parties, prompted by Greenpeace criticisms and concerns. And we assessed against those 56 requirements of the guidance. And basically, this is a summary of the results. Of those 56, green means there was information. Compliance was defined by there was information provided such that a decision could be made that it's in compliance. Yellow means there's partial, and red means there was no information, there was no compliance on those. But there we are, with about 80% of those 56 requirements were they were in compliance. The information was provided in the opinion of TNO. 18% were only partially met, and a small number were not met. So, of course, we're interested in the ones that were partial or not met. And there's different reasons for these. The P18 field is a depleted gas reservoir with a single well. They thought the likelihood of leakage was minimal, so they didn't do a detailed environmental impact assessment at the seabed. The question was proposed that they could use material from the other work, such as the European projects, maybe for the environmental impact assessment. But 5.2 there is around the use of the presence of incidental substances. They did provide the list of incidental substances in the CO2 stream, but they didn't develop a screening tool or a national action list, as it's called. And the red was just basically because they didn't include permit update requirements in there. So this is the report, and this goes down. It shows that you can be compliant with the London CO2 specific guidelines, both by the regulator and the operator. And we had this presented in the London Convention meeting in 2016. And for the first time ever, I got a thank you from Greenpeace. This is the sort of transparency they wanted. And there's a bunch of recommendations in there, which I won't go into more. And just the last update. So I didn't present this to the London Convention meeting, but there was lots of questions around this export aspect. So the London Protocol has an export prohibition to stop countries exporting wastes to other countries that are not in the London Protocol as a means of dumping it in their waters. So you can't export waste for dumping, but that also stopped you from exporting CO2 for geological storage in another country's geology. So this amendment came in 2009 to allow that. And the requirements are that there has to be an agreement or arrangement in place between the two countries to make sure that all the aspects of the CO2 specific guidelines are covered. But because this is changing a body part of the London Protocol, it needs to be ratified by 2/3 of the countries instead of the original amendment, which was to an annex. So after 10 years, we'd only had only a handful of countries, 6 countries had ratified it. So it was a long way from coming into force. And Norway was developing the Northern Lights project, which relies upon taking CO2 from other countries. So in 2019, after lots of legal work by environmental lawyers, they thought there's a way forward if they could get all the countries to agree on a provisional application of that 2009 amendment. And this was approved by voting. And so, yes, countries who want to now can apply that and export CO2, receive CO2. So that's good. That barrier was removed, and that enabled the Norwegian government to say yes to the financing of the Northern Lights project, with its MOUs already in place for the CO2 from different countries. So, yep, and the guidance, we updated the CO2 specific guidelines to take this into account, and also developed some guidelines for what needs to be in these agreements and arrangements. That's buried in London Protocol meeting reports. So co-authored with the Secretariat of the London Convention, we produced an IEAGHG report to draw these out, to help countries, to help regulators, to help project operators in exporting their CO2. An update on this. Countries declaring they're going to do this provisional application. We now have Norway, Netherlands, Denmark, Korea, Belgium, Sweden, UK, and Switzerland most recently. The first country to sign an agreement or an arrangement was Denmark with Belgium in September 22, and that was for the Green Sands project. And they exported CO2 for their test injection early in 2023. So that was the first use of this. And then a week or two after that, the European Commission produced an analysis paper that said that the CCS directive serves as an arrangement. So EU member state countries don't have to go into great detail in these arrangements or agreements, but just cover the bits that aren't covered in the CCS directive. And that's basically around which body in which country is responsible for permitting which aspects. And then recently this year, Denmark has agreed with France an MOU, and the Netherlands and Norway in April has agreed one to export CO2 from the Netherlands to Norway. In the meantime, the original amendment, it's hardly moving in terms of ratification. Switzerland has done it, but countries can now export, so that's good. So what happened 2 years ago then in the London Convention is that Japan wanted to, I don't know, get more experience, get more knowledge about the experiences of using these CO2 specific guidelines for permitting. Bearing in mind, we haven't got many projects operating offshore. We've got 4 projects in operation, but they wanted to, get more knowledge on this. So they set up what's called a correspondence group, a working group in the London Convention, the broader convention. And they did a survey. The survey asked questions around, do countries have regulations in place? Do they have projects? Do they have export-import agreements? Do they consider alternatives to offshore storage? Do they have a national action list? CO2 from multiple sources? Cross-border storage? What regulations on pore space ownership? What do they do for site characterization? Liability issues? The regulations on wells? The risks of induced seismicity, are they covered? Monitoring frequency? Potential for monitoring leaks? Public consultation? Permitting periods? Alternatives to saline formations? I think that's looking at mineralization and storage in basalt. An interaction between storage, apologies for the typo, and enhanced oil recovery. And are there any other issues not covered? So they put this survey out, and 18 countries responded to this survey. And I say 18 countries, these are the marine regulation parts of these countries, of these governments. And what we had in the scientific group meeting in April in London was one day dedicated to discussing these findings. So it was interesting because when we looked at what countries had responded, they hadn't, we only have 4 operational projects offshore and 2 in the process of applying for permits now. So there's very limited experience. So these bodies, these regulators were applying without real experience in most cases. There's 18 countries responded. So for the day dedicated to CO2 permitting experiences in April, they had presentations on the London Convention background, the history of it. The presentation I gave, which is a version of the one I've shared with you now. They had a presentation from Australia on their regulations. Now I mentioned about the incidental associated substances should be based upon a risk assessment on impacts on storage sites and transport and the marine environment and human health. Australia has gone to develop a national list. I mean, they are called national action lists, and they are generic lists that the marine regulators have a list of things that be not put into the oceans. But Australia's developed one specifically for CO2 geological storage. So that's the first country to do that. The other countries are doing it on a project by project basis. And Australia's got these an interim national action list. It says 95% CO2 in the CO2 stream. Other gases have to be less than 4%. And then very specific parts per million in the liquid form of CO2 for other substances, including H2S. So they've produced a national list of these incidental associated substances. From the US, we had BOEM presenting, but it wasn't to do with their Oxler developments. It was to do with their methodology for storage potential offshore and using their geological resource assessment program, GRASP, which you might be familiar with. We had a presentation on ships, presentation from the regulator in Italy, presentation on Korea, Norway, and Japan. And what we got was Greenpeace were very interested and active and asked 3 questions of every presenter. And these were written up afterwards, and they are in the meeting, both in the meeting report, but also in a working paper for the London Convention. So these are in the public domain. And they said they are concerned about the export and import of CO2. Who's responsible for the CO2 stream composition? Well, that's actually in the guidance documents, but it wasn't clear in these responses from the 18 countries. How do you limit CO2 to just the hard to abate sectors? They don't want CO2 from the power sector going into the offshore storage. And Germany also said this in the meeting. Their offshore regulator said this. How do we stop CO2 from fossil power going to offshore? And because I had the chance to speak and everything there, I pointed out that we'd already had this discussion, and the London Protocol is about protection of the marine environment. And where the CO2 comes from is up to countries' climate and energy policy. And that's not the remit of the London Protocol to determine what the climate and energy policy is of a country. But nonetheless, they were asking for this limitation to come in. They were concerned that there was different interpretations of overwhelmingly, even though, you know, we had all that history behind that. No experiences with multiple sources yet, but we have the Northern Lights coming along. Some countries are not monitoring leakage pathways. That wasn't in the responses, but we know that we can do that. No experience with assessing risks of induced seismicity. Well, with seismic monitoring in place and microseismic monitoring, it's implicit in those projects, MMV plans, but it wasn't drawn out in the responses. And there's no, or not much experience in monitoring for leaks, particularly in the far field away from the injection point, nor confidence in leak detection techniques. So again, I had the opportunity to push back on that and say, we do have a suite of techniques now for the STEM CCS project in particular, but also QUIX and ECO2 projects in Europe. So we do have the ability to do leak detection, but the lack of experience is also related to the fact there's only 4 operational projects and none of them have leaked either. We've had to, and I said, we have to engineer leaks to test these sensors. We have to have engineered leaks, MCCS and QUIX. And they were Greenpeace was quite mischievous in bringing CO2 EOR in. The CO2 EOR is not regulated by the London Protocol. It's oil and gas production, but they expressed concern that the majority of CCS projects in the world are EOR-based. Petroleum-based regulations, where there are going to be double standards, where CO2 EOR projects include CO2 for storage, and they've introduced that out of mischievousness, in my opinion. So I'm almost at the end now. So this is a bunch of good questions. And the correspondence group, the agreement then was these questions need to be addressed further They're now written down in the meeting report. The correspondence group will continue and report back in a year's time. So does this matter? Well, these are now public, on the public record, these concerns, and I could push back on some in the meeting. We're the only CCS organization in the room in these meetings. But it concerns me a bit because they're on the record and they need to be countered to avoid them becoming sort of understood to be genuine concerns when it's more to do with lack of experience. So what I thought we could do, working with our colleagues here, is look at these points and these questions and concerns from Greenpeace and discuss them in our offshore workshop, which is this September, but also in our monitoring and risk networks next year, and be active and input to this correspondence group. We did this model as IEAGHG for CCS and the Clean Development Mechanism in the UNFCCC. The issues of concern that were raised there, we took to our networks, our monitoring network, risk network, etc., discussed them, and then presented the results back in person in a technical workshop in Abu Dhabi. Catherine did, and Richard Metcalf, Andy Chadwick. So we can do that again here. And we have that workshop coming up. So I think it's important to do because this goes on the public record. If people wanted to be mischievous, they could be where Greenpeace concerns have been raised and not answered. But also the CO2 guidelines, and they're guidelines, they're not a legal document. That means they could be easily revisited. So there could be a conclusion by the government members of the London Convention that we need to revise these CO2 specific guidelines, and they could be made more stringent. And a general point I'd make is that these were written in 2006, 2007. We have a lot more knowledge now, a lot more confidence in CO2 geological storage. We don't want to go more stringent than what we were then when we were more cautious. And I said that this week in a workshop in Oman on Tuesday, where they're developing their regulations. We need to not go backwards on these things. And the work that the BEG does with your science and research and projects and developments offshore, marine monitoring, the projects that are 50 projects that are potentially in the Gulf of Mexico. It's all really important to feed this information in to this regulatory body instead of moving the world forwards to stop it from going backwards in a sense. But anyway, that's what I thought I could share with you today. Material for us to work with. And I must say, the individuals from Greenpeace that I work with, I've worked with them for 20 years. We have a very good working relationship. We have different opinions, but we are very respectful. It's a very respectful environment, unlike the UNFCCC and COPs, where people get angry and shout and protest. It's not like that at all. And they're very, open to good science being input to that. And that's what we hope to do. So thank you very much for listening.
Thank you, Tim, for that. Great talk. So much going on. I don't know what we'd do if we didn't have you to keep track of it for us and stop it going backwards. So really glad about that. Do we have any questions?
Oh, no, apologies, I went over time a bit as well.
Thank you, Tim, for the presentation. I have a question about why was the reason they want to limit CO2 to and from hard-to-abate sectors?
Yes, it's a good question. And it comes from this fossil fuels are bad ideology, that we've got to stop using fossil fuels. So anything that allows the continued use of fossil fuels, for example, in power generation, where there are alternatives for power generation from non-fossil fuels, so wind, solar, nuclear, for example, that comes from that anti-fossil fuel thinking from Greenpeace, IEAGHG is another environmental NGO, but the German regulator is saying this as well. So it comes from that. And my answer to them in the meeting was, one, it's not in the remit of the London Protocol, but two, even with high penetration of renewables in your electricity system, you need something to counter the variability of renewable electricity. So you do need something else, and that's likely to be gas power. And you still don't want those CO2 emissions from that. So it needs to be gas powered, CCS on it, was my answer. And when they came back again on this, and I did make the point that the CO2 is just, if you don't want it from the carbon capture on your power plant, that CO2 is just as harmful to the environment. Are you condoning the emission of CO2 from power generation then by implicitly in that? So I think that's the thinking. It's that anti-fossil fuel thinking coming in. And I say climate science, is about what goes into the atmosphere that counts, not what you take in or out of the ground.
Thank you.
So,
geoscience question follow up from Argenis's question. So Greenpeace and this German group, where do they think it's right to get your power from? What's okay? What is it they want to do? Is nuclear back on the table? Are they considering nuclear? Or
yeah.
and how do they feel about batteries? Do they allow those things?
Yeah,
what we need to do is say, okay, which things do you think, batteries are lots better environmentally than CCS? Is that where, and then CCS? So that, and I'm not sure that question ever, I don't know who's working on that part. It's outside of my domain.
Yeah, I don't know if they would have the answer to that, but Germany is an interesting case
because that's the frame of the question. Is okay, no power. People should get no power. That's just question A. If they get their power, where is it acceptable for your standard, what did you call it? You had a nice nuanced word from your perspective. Where is okay for them to get power? Which of these technologies are you taking off the table? And and it might be the first one. No, people should just do with less power. That's it. And then which would be a clarifying at least what their stand is. My house, we're trying to use less power. It's okay. But I do, and I haven't bought batteries. I don't know.
So all these people in the London Convention their day job is marine protection. So they don't think about electricity supply and everything. And back in 2006, Germany pushed back then. And that frustrated me because the German government has, after Poland, it's the next biggest emitter of CO2 due to its coal power generation. And then since then, because of Fukushima, they've closed down their nuclear side. They've got very positive, aggressive support for renewable electricity, but that's still not countered their emissions going up from coal power generation. So they really are, dirty man of Europe in CO2 senses. For them to be, for one agency of the German government to be arguing, we mustn't take the CO2 from our coal power stations and put it offshore, doesn't really make sense. It's
Hi, Tim. Fascinating talk. Kind of interested in how does this relate to the current situations in the United States? The federal government has been instructing the BOEM to promulgate a regulation for CCS in the federal offshore, right? I think it opens up a great opportunity in the Gulf of Mexico region in particular. I was wondering, from all these experience in recent years, what's the, I guess, key lesson learned that could be, or perhaps some sort of a low-hanging fruit that can be applied to the federal offshore in the United States? And what about the U.S., particularly onshore, has a Class VI well permit? What do you think that would be very relevant, in terms of, I guess, an objective that could be adapted to the federal offshore that could perhaps ensure that the CO2 remains in the subsurface while also expediting the permit process?
Yeah, so I think that work is underway at the moment by BOEM. And so we are waiting to see whether they translate the Class 6 requirements to the offshore. They're not. Sue's got the inside knowledge on these things. But I think my understanding is they want to draw from their oil and gas permitting knowledge and capability that they have at the moment and adapt that for CO2 storage. So that's as much as we know because they've not shared anything publicly yet. They're hoping to do so later on this year. But they do have to meet the requirements of the London Protocol. But one of the points I would make is they're not really stringent requirements, and they're very, very qualitative in nature, as we showed through our report. And the London Protocol isn't a body that turns down your permit. It's not, it doesn't have that power to do that. So it's quite, you know, given that, it's really been effective in stopping dumping nasty industrial waste in the oceans. But it'd be fairly straightforward to meet the requirements. You've just got to address those issues and make sure they're considered in the permit applications. So I think it should be fairly straightforward, but I'd look forward to seeing what the OEMs actually going to produce and put out to consultation. So that's not a very specific answer to your question, but it's work in progress. Yeah.
Really good question. And maybe we can talk more about that as well in the offshore
Charles.
workshop.
Charles had a
Okay,
question.
we're running low on time, but
Tim, simple question really. Why does Greenpeace have standing to be present at this meeting? I mean, it's not an elected body.
No, so the London Protocol allows observer organizations in, and they have a seat in the plenary, and IEAGHG, we're a recognized NGO organization as well. So it's a way of getting others, I guess, stakeholder interest reflected in their meetings. Why, when they have the drafting groups, they allow the observers in at the table, I don't know. But it does mean that the regulations that come out, the guidance that comes out, has had Greenpeace involvement. It's got a Greenpeace stamp. Greenpeace are co-authors on it. So if you can, you know, that's a positive thing as well, I think. It helps to address or head off criticism that might come from them otherwise. In the UNFCCC, it's purely country-to-country drafting and negotiations.
and
But you
is
think
it,
it's wrong. Okay.
is it,
Got
So-
a good right to be there.
Yeah, so you have to apply, and you have to meet some basic criteria to qualify to be an observer organization.
but do they take is it a majority when they decide on things?
They don't get to vote. They don't get to vote.
Okay.
So observers don't get to vote, but
And-
they get to speak.
And does it like the UNFCCC where everybody has to agree 100%, or
No.
anybody that has a vote?
It's different. Thank you, Catherine. Good point. UNFCCC is consensus-based, so everything has to be agreed by all the 197 countries. It's like to get anything out of the UNFCCC is an achievement, and we have, you know, Paris Agreement, CCS, CDM. It works by no one country objecting strongly. That was because they failed at the beginning of the UNFCCC to agree the rules on decision-making. There was proposals about majority voting, and things went wrong. London Convention is how it is more conventionally done. So 2/3 of the countries need to be in favour in a voting. It can be consensus, but if there's not consensus, 2/3 of the countries have to vote in favour for whatever the thing is they want to change. But observers don't get a vote.
Okay, thank you. Well, we've gone over, so let's thank Tim again for coming. Thank you so much, Tim. And we have a few people going to lunch. You know who you are. Let's meet down by the front desk, please, and then we'll all head over together. All right, thanks, everybody.